Perfect. Thank you, Liz. All right. Thank you, everybody, for joining us today. My name is Mitchell Pearson, and I am a business intelligence consultant for Pragmatic Works. And today our webinar is going to be on SSIS performance tuning. Brad Schatt was going to be doing the webinar today, but unfortunately he had some meetings that he could not get out of. So he asked me if I could cover for him, and I expect that he will actually be on here later on. So if you have any questions directly for Brad, or if you have any questions here at the end of the meeting, he will probably jump in there and help answer any questions that you might have. So a little bit about me. Once again, I'm a business intelligence consultant for Pragmatic Works. I blog at mitchellsequel.wordpress.com. I have a lot of good blogs there on SSIS, and some of those are on performance tuning as well. My Twitter handle is mitchellsequel, and you can also contact me here at Pragmatic Works on my email, and my email is mpearson@pragmaticworks.com. As far as the SQL Server community goes, I'm pretty active in the community. I've spoken at many SQL Saturday events here in Florida, as well as the local SQL Server user group. So we have a SQL Server user group here in town, the Jacksonville SQL Server user group, and I've spoken there as well, and I believe I've been a member there for about 2 years now. All right, so let's talk about the agenda today and what we're going to be covering. The first thing I'm going to go over is I'm going to talk a little bit about best practices when creating your SSIS packages, and then we're going to transition into blocking versus non-blocking transforms. Sometimes you're going to have to use blocking transforms in SSIS, but we're going to discuss how to mitigate those issues when you don't have to use blocking transforms. And we'll discuss a little bit about why blocking transforms inside of SSIS are not good for performance. And then finally at the end, I'm going to cover a couple examples of real-life performance problems that I've ran into out there in the field and some of the solutions that I was able to implement in order to improve performance inside of SSIS. So I'm going to jump into SSIS here, and I have a solution here that I've created for today's presentation. And the first thing I want to talk about is using select star or selecting table or view from your source or your lookup component inside of SSIS. So if I open up this data flow here and then I open up the old DB source component, you can see that in this demonstration here I selected table or view, and I've selected my dim employee table. Now what that's going to do is it's going to bring in all of the columns from the dim employee table, and it's going to pass those through my data flow whether I need those columns or not, which means it's going to have to drag all that information across the network. It's going to have to pass all of that information into buffers inside of data flow, and then it's going to have to process all of that information. That can be extremely heavy on performance and degrading to the performance that you're going to receive. So I've created a very basic demonstration here to show you the difference as far as the performance you should expect if you're going to select a table or a view, and the performance that you will get if you actually select only the columns that you need to pull back from the source component. So if I run this package here, and let me go ahead and give you an idea of what's inside of that table there. So this table has probably somewhere around 20 columns of varying length in data types, all right? And if I go ahead and run this package here, or just this data flow, it's going to run pretty quick, all right? It's a small dimension. I think I only have about 500,000 records in here. And I'm going to flip over to the Progress tab. That should complete here in just a second. All right, 501,000 records, and that completed in 12 seconds. So not too bad, right? Now I still caution you that this is everything that I'm doing here is local. It's on my local machine. I have an SSD. I have a pretty nice computer here, but this is a small dimension, or this is a small record set. So you got to be very careful, because as you complicate your process and add networking issues and other things inside of your environment, it could perform much worse. Now if I flip over to my other data flow here, select 2 columns, and I open that up, I'm going to show you what I got. So instead of bringing back 20 columns, which is what you saw in the other table here, or the other data flow, I'm only going to bring back the 2 that I need, right? So I'm just going to bring back the surrogate key here and the business key. And if I go to columns, you can see that that's all I've selected. So I'm going to stop processing the other one, and I'm going to go ahead and execute this package here. And visually you can see, before I even flip over to the Progress tab, visually you can see, hey, there is a significant improvement here, right? So if I flip over here, you can see that this ran in about 0.8 seconds, not even 1 second. The other one that we ran just seconds ago took 12 seconds to run. It took 12 seconds to execute. So there is a huge impact to performance if you select only the columns that you need. I don't see as many clients doing their select and then table or review in the source as much as I used to. And I saw from the survey that we did just a moment ago that a lot of people do not consider themselves even beginners anymore. We have a lot of intermediate level SSIS developers on the call today. What I do see, though, is I see the table or view or the select star being used in lookup components a lot of times in SSIS packages because, of course, that's quicker for development and that's easier to do. The problem with that is you need to understand that 99% of the time, if you're performing a lookup inside of SSIS, and I'm opening up a new package here, 99% of the time, if you're performing a lookup inside of SSIS, you're going to use this full cache mode here, right? And the full cache mode is going to put everything into memory. So if you're pulling back a larger data set than what's required, you're going to be consuming a lot more SQL Server memory than you need to require or that is required. And that can definitely hurt not only the package that's running, but other packages that are running at the same time. So to demonstrate this without even setting this up in a package, I've created two separate tables right here inside of my Object Explorer. And let me zoom in. Hopefully everybody can see my screen okay. And if you can't see my screen, just say something in the chat window down there and Liz will let me know, and I'll definitely use my zoom tool a lot more here. But I have my dim employee table that I just showed you a minute ago, and that has probably 20 or 30 columns here. And then I have my dim employee two columns here, and it's only got the 2 columns that I require. So imagine here that I run a select statement that is only going to bring back the 2 columns. And in this other one, I'm doing a table or view, right? Which you'll see, and I'm just going to use space used on these 2 tables here. And let me bring this information together. All right. What you're going to see here is that the first one that's doing the select star, or bringing back the entire table, is actually going to cache about 343 megs of data into memory. The one that's only bringing back the 2 columns that's required for that lookup, or even in the old DB source, it's only going to cache about 13 megs. So up here you got about 343 megs, right? And I'll go ahead and write that out. And down below you're only going to be caching about 12 megs. Now you can think about that in terms of SSIS packages that you have in your environment, and some of those packages probably have 10, 15, 20 lookup components inside of them, and it's doing this for every one of those lookup components. It's taking way more data than it needs to, and it's caching that into memory. So this is something you definitely need to look out for in your lookup components. Once again, I've seen this cleaned up a lot inside of the old DB source, not quite as much inside of the lookup components inside of SSIS. All right. So there's something else that I want to show here. And I'm going to go ahead and execute this package. So inside of this package, I have the example that I want to show first, and then I have a revised example. I'm going to execute this task right here. And then I'm going to flip over to the Progress tab and give you a little bit more information of exactly how the lookup transform processes, or how SSIS processes those lookups and how it caches that information into memory. So if I come down here and I zoom in, there's a couple things I want to show you. The first lookup inside of my package was this lookup due date. Well, it's not the first one in the package actually, but it's the first one that SSIS decided to cache into memory. And it's going to cache 2,000 rows. It's a very small dimension, and it took it 0.016 seconds, and it cached approximately 1 million bytes of memory here. Now notice that it did it here, it cached it in memory, and then it's going to go down and it's going to cache the order date key, and it's going to do the same exact thing. 2,000 rows, 0.001 seconds, 1 million bytes of memory. And then it's going to process my third lookup, and it's going to process 600 rows, same thing, it tells me my time and my memory, and then it's going to do my fourth lookup. So in this package I only have 4 lookups. The thing that I want to take away from this, and that I'm going to discuss in just a second here, is that the first thing it's going to do is it's going to process this lookup here. For whatever reason, SSIS decided to process that lookup first. And then it's going to process this lookup. When it gets done with that, it's going to come down here and it's going to process another lookup. And it's not doing these in parallel. Once again, typically this is not going to be an issue inside of your SSIS packages, right? And so it's going to process this one. Once it's done with that one, it's going to come down here and it's going to process this one. Once it's done with that one, it's going to process this one, okay? So it's doing all of these lookups in serial. The other thing I want to point out is that this ship date key, this lookup transform that I'm doing right here, and this order date key lookup, and the due date lookup, all three of these lookups are actually the exact same result set, which we can see here with the rows and we can see here with the bytes of memory. So let me show you that inside of the package. So I'm going to flip back over to the control flow here, and I'm going to stop debugging, and I'm going to open up the order date key. I'm using an OldDB connection manager. I'm using the full cache mode, and inside of my connection you can see that I've written a query here, right? Select date key, full date alternate key from dim date, and then on my columns I'm doing my match and I'm bringing back my date key. If I come down to my ship date, I'm doing the exact same thing. OldDB connection, I'm bringing in the exact same query here, and then I'm doing my connection again. This is very typical of what you might see when you're loading a data warehouse, especially when you're loading a fact table. You're going to have these role-playing dimensions where you're going to do the same lookup to that dimension multiple times. The unfortunate thing, and what you just saw when we were looking inside of our execution results here, is you saw that it's doing that same lookup and having to cache that information into memory, right? So if this was a larger dimension, you could see here that it's caching that same result set 3 times, and it's consuming 3 times more memory than it really needs to consume. So I'm going to show you how you can mitigate that here inside of SSIS so that you're not going through that every time that you do that. And there are definitely going to be dimensions that are much larger than that, like maybe a customer dimension or a product dimension, where you don't want to cache that information 3, 4, 5 times every time that you run that package. So I ran this package. You saw how it did that in parallel. This sequence container over here is using a little component inside of SSIS called the cache transform. Now, once again, this is a component that I haven't seen used by a lot of clients out there in the field, but it's one of my favorite components, especially for mitigating some of those memory issues that I just discussed. All right, so what I'm going to do is show you inside of this very first data flow what I have going on here. So this OldDB source component is running that exact same query that you just saw in all 3 of those lookups. Okay, the exact same query that we just saw in all 3 of those lookups is being done right here inside of this OldDB source. And then I'm taking that information and I'm loading that into cache, manually putting that into memory, and I'm giving it a name, and this is the cache that I'm actually going to reference inside of those lookup components in a moment. And this is how I'm going to reuse that same memory and only use it 1 time. So I'm not putting that information into memory 3 times. And this is actually extremely easy to set up, and that's why I'm very surprised that I don't see this more out there in the field when I'm working with clients. Okay. So what I want to do here is let me go ahead and find this cache transform over here under Other Transforms. And as you can notice, I am using SQL Server 2012. Over here under Other Transforms, I'm going to pull in a brand new cache transform real quick, and I'm going to show you just how easy this is to set up. Okay, I'm going to go ahead and get rid of this data flow arrow here. It's not going away. Let's try it one more time. Okay. All right, and I'm going to hook up the new one here. So when I come in here, imagine that I don't have an existing cache connection manager, and I'm going to press New. And we'll call this cache. Okay, so it appears that the battery on my keyboard died. So let me move that out of the way here. And that's not working as well. Maybe it's not the battery. Sorry guys, I'm having some technical problems here with my keyboard. It's not wanting to allow me to work. Hey Liz, if you're out there, can you go ahead and take the presenter away from me real quick and then give me a presenter back so I can see if that resets my keyboard?
Yep, not a problem.
For some reason my keyboard is not working with the GoToMeeting, but it is working outside of the GoToMeeting here.
Okay.
Thank you, Liz.
Mm-hmm. Try it now.
It is not working once again. Okay, so let's say that this cache connection manager, I'm just going to call it cache demo real quick, okay? And I've actually typed this into Word here and copied it over. And all you need to do to set up this cache connection manager is it's already done everything for us. Remember, all we've done here is hit new connection. That's all we've done. We've hit new connection and we've set up a connection manager name. And the connection manager name that I'm using here is just cache demo. No big deal there. This file cache option here will actually allow you to take all of that information and not put it in memory and actually persist that to disk. So you can store that in a file location and then use that across multiple packages, okay? I have a really good blog out there on my website on this, on how to use this file cache to actually mitigate network issues that you might have, okay? So let's flip back over to columns here, and I'm going to show you all you need to do to set this up. It automatically brings in all of the metadata from the data flow arrow that we just hooked up. And I need to set my index position. The index position here is going to be the full date alternate key because this is what I'm doing my join on inside of my package. So I set that to 1, I click OK, and then all I have to do is make sure everything's mapped and click OK again. And once I've done that, it's fully configured and it's ready to go. And you can see now I have this cache connection. I didn't give it the right name here. But that cache connection has now been created. So I'm going to get rid of that one. Oh, it allowed me to delete. I think we're back in business here. And I'm going to hook back up to this one here. And what I want to show you is in this second data flow here, exactly how you set up that cache connection manager, right? So we know we want to use it. We know it's going to improve performance. It's going to mitigate some of those memory issues that we might have. But how do I set that up inside of my lookup component? And the good news is that this is extremely easy to set up. Now, in some of the previous demos that we've done, we saw that we were using this old DB connection manager here. In this example, I'm going to use my cache connection manager. And then the difference here is going to be on the connection tab. Before, we had to come in here and we had to write our SQL statement, right? We had to say, hey, select full date alternate key, comma, date key from dim date. Now we don't have to do that. All of that information is contained inside of this cache, inside of this memory. So all we have to do is select that from the top, come over to columns, map everything up, and then everything is set up exactly the way we want it. So it works out extremely well, and it allows us to mitigate some of those issues. Okay, so I'm going to run this package, and then I'm going to show you in the execution results exactly what we were looking at before, but I'm going to show you that SSIS is only going to cache this information into memory one time. So I'm going to execute on the container here. I'm going to right-click and go ahead and execute container. Okay, so if I come back over to progress and I come down a little bit, I'm going to see right here this cache transform. And it shows me, hey, I am reading out 2,191 rows, 1 million bytes of memory here, and it took 0.001 seconds. Now, let me change my zoom tool here. If I scroll down to where the data flow task starts, you're going to notice that it does not do any lookups here on any of the date lookup components that we have inside of my package. The only lookup it's going to do is the old DB connection manager for the product key. Those other dates don't get any lookup done at all. So this is a very simple example of how you can use that cache transform to save memory in your SQL environment, and especially within SSIS. And once again, this is a tool and a transform and a component inside of SSIS that I very rarely see other people using. So I want to point to one other thing here. Remember at the very beginning of this demo, and I'm going to go ahead and stop debug, and I'm going to flip back over. I want to show you one other thing that you can do with the Cache Connection Manager that is really cool. At the beginning of this demo, I ran this package or this data flow task right here, right? And when we went into the progress results, we went into the execution results, you could see that it was doing the same lookup multiple times. But it's doing 4 lookups here. It's not doing those lookups in parallel. Typically, that's not going to be a problem. It's doing it in memory. It's extremely fast. Not when you're working with small tables. If you're working with small dimensions or small lookups, that's not going to cause a problem. But what if you're not? What if you have a situation where you have to do a lookup against multiple tables that are very large, 15, 20 million records in size? What you're going to do is you're going to come in here and you're actually going to have to wait. You're going to have to wait for it to cache that first lookup and cache those 15 million records into memory. And then it's going to come down here and it's going to cache the next lookup, and it's going to cache those 15 million records into memory. It's going to do it again here, and then it's going to do it again here. The reason I bring this up is because this is one of those real-life scenarios I was talking about in the introduction. I was working for a client. We were doing a load of a snapshot fact table, right? And in order to load that fact table, we actually had to do lookups against multiple other fact tables. And each of those fact tables had somewhere between 10 to 20 million records. It was taking a very long time for SSIS to process all of those lookups because of the process that it was going through. The awesome thing about the cache transform is that you can actually force SSIS to cache that information in parallel, which is pretty awesome. So let me show you how you would do that. And I'm not going to go through and actually write the queries for all of these, but I'm going to show you a little bit of how that package would look, okay? So I have a sequence container here. And inside of that sequence container, I would have a data flow task that is caching my date dimension. I would then have another one here that is building a cache out for, let's say, my customer dimension, okay? And then you might have another one here that's doing the exact same thing, and it's doing a lookup, or it's loading a cache transform for, let's say, my dim employee. All right? And now what I would do is, before I actually run this data flow task here, so let me go ahead and copy this out to give you an idea of what the design pattern would look like here. Before I run that data flow task, it's going to run all of these data flow tasks in parallel inside of that sequence container, and it's going to cache all of that information into memory. And once this completes, then it's going to come down and it's going to run this data flow task down here that's going to load my fact table. And every one of my lookups in here would all be referencing their corresponding cache transform that we just created in the previous sequence container. So I went through that pretty quick, but I hope that made sense. Essentially what you're trying to do there is you're trying to make sure that SSIS is not doing this in one-by-one operation, but I'm forcing it to do all of those lookups in parallel. Once again, this is one of those one-off situations. Typically, you're not going to have to do this inside of your environment. 90% of the time, I would say you don't need to do this, but there are probably some good use cases out there where you could implement a ETL design similar to this that would actually improve performance in your environment. Okay, so I'm going to go ahead and delete this here because I don't need that. I just wanted to demonstrate, exactly what that would look at, or exactly what that would look like. Okay, so let me save that, and I am going to open up this module 2 SCD. Now, what I want to discuss on this one is something else that I've actually seen. So I've been working with some people here that are pretty new to SSIS lately, and something that I've noticed is some pretty simple basic concepts that everybody should definitely know and understand when working with SSIS. So I just want to point these out real quick. This looks like a very busy screen. Don't let it overwhelm you here. These two tasks here are just doing some basic setup for me so I can run these other three components. So I'm going to run this one right here, and it's going to just truncate my employee dimension table so that I can reload that table. All right. And then this very first one is going to demo a setting that I want to talk about inside of your old DB destination. All right. So a lot of people don't understand this, but inside of your old DB destination, you actually can do a row-by-row load, or you can do bulk inserts. And what I've seen is, and let me zoom in here so you can see what I'm looking at. I've seen a lot of times when you're having performance issues that this is what was selected, table or view. Table or view is going to do a row-by-row insert into your database, which is going to perform very, very poorly. However, if you come back in here and you flip this over to table or view fast load, that's actually going to do a bulk insert in the background. And let me demo that for you. Okay, so I'm going to open up SQL Profiler real quick up here at the top. If you're not familiar or you've never used SQL Profiler before, SQL Profiler is actually a really cool tool. So let me go ahead and zoom in here. And on tools inside of SSMS, I'm just going to go ahead and open up my SQL Profiler tool. All right, and it's popped up in the other screen here, so give me just a second to get my mouse over there. Don't do this to me. Hold on. Where is it at? Okay. All right. I cannot get my mouse. Oh, I know what it is. All right. My zoom tool almost ended the webinar there. I was zoomed in and it wouldn't let me change screens. Okay. So let me do this one more time. Let me show you from the beginning here. So I opened up SQL Server Profiler, and what I want to do is I want to click on New Trace right here at the top. And when I click on that little button, that New Trace button, it's going to ask me what database do you want to connect to. I can connect to Analysis Services as well. And I'm just going to hit Connect. And when I hit Connect, it's going to give me a screen here. And I'm not going to change anything here. If you wanted to, you could go into Event Selections and you could really filter this out. There are some great blogs out there in the SQL community on how to really use the Profiler tool. But I'm going to show you here a really cool example of what's going on when you select Table or View and when you select Table or View Fast Load. And you can use this tool for other performance tuning issues in your environment, not just for the demo that I'm going to give you here today. Okay? So I'm going to go ahead and click Run. I'm not changing any settings. And this is going to show me any statements, SQL queries that are being run against my database. So I'm going to come back over here to my SSDT SQL Server Data Tools, and I'm going to go ahead and execute this package here. All right. So you can see that I think I have somewhere around 500,000 rows, and it's inserting those rows into the destination here. And this is actually performing pretty slowly. All right, so it's pulled 50,000 rows in from the source. It's got 39,000 rows down here at the bottom, but at this time, it still hasn't completed. The package is still running, okay? So now it's done. I'm going to flip over to the Progress tab, and that took 20 seconds, all right? 20 seconds because it was not doing a bulk insert. And what I want to show you here is if I go back over to SQL Profiler, and I'm going to go ahead and stop this trace, it's running this execute SP cursor command for every single one of those records there. So for all 50,000 of those records that just got loaded into that table, it ran this cursor command, and it's performing extremely poorly, right? So that's just something to watch out for there. You don't want to select Table or View. You definitely want to use the bulk insert method when applicable. And another thing you can look at here is if I go down here to the bottom, you can actually see how many records are in my profiler here. And there's 51,000 records. And that kind of shows you how many times, if I scroll up, you'll see the same command over and over again. For every single record that got inserted, it had to pass those parameters in, and it did it on a one row-by-row basis. All right, so I'm going to go ahead and clear this, and I'm going to flip back over to SQL Server Data Tools. I'm going to go back into my data flow, and I'm going to stop it. And what I want to show you here is that took 20 seconds to run. If I open up this OLDB command and I change this to Table or View Fast Load, if I don't change anything else, if I leave it exactly the way it is and click OK, it's now going to run a bulk insert task. So I'm going to go ahead and run that, or a bulk insert command against the database. And I'm going to run that. Visually, you can see that performed much faster, right? Much more efficiently than what we were previously working with. And instead of 20 seconds, it actually only took about half of a second, 0.5 seconds for that to run, all right? So if I come back over to Profiler, and I didn't run my trace, so let's run that real quick. I think we have half a second to run this again. I'm going to go ahead and run that one more time. And what I want to show you is the difference of what's going on in Profiler. Remember before we had 50,000 records here? Now when I come down here, we only have 62. It did not run that insert command for every single one of those records. It actually did a bunch of bulk insert commands here. And you can see that it's saying, hey, insert bulk into this table. And it's doing that using the bulk insert command. All right, and it performed, what, 40 times faster? It took half a second instead of 20 seconds. So that's just another tiny little tidbit there, something that I've actually seen being used out there in the field, maybe because of all the options that are available with the fast load. People are intimidated by it because there are a few extra options, but you pretty much always want to use the fast load option when applicable, all right, which is always. Okay, so that was just a real cool little demo on a best practice that you want to implement inside of your environment, all right? So the next thing I want to show here, and this is another really cool example, all right? So let me go ahead and throw up the whiteboard here so we can talk about it. I was working for a client, and they had a lot of flat files. They had somewhere between 7,000 to about 16,000 flat files for any given source, right? And we probably had 10 different sources. And when we set that up originally, we set it up using a for each loop container. And if I asked the 203 attendees that are on here today, you know, what component would you use to do that, to loop through those files, you would say, hey, I would use the for each loop container. That is, of course, going to be the first thought process that we're going to go through there. However, what we found out was that the for each loop, it takes time for it to go out there, get that file, pass that file into a variable, pass that variable into the file connection manager, and then process that file. It takes time to do that typically you don't see, and you don't see it because you're working with a very small number of records, maybe 100 or a couple hundred records. But when you get up to 7,000 records, imagine I have 7,000 records here, and it takes maybe 1 second for the for each loop to process 3 records, to actually go out there, get a file, and pass those parameters in, right? So I got 7,000 records. If I divide that by 3 seconds, that's going to come up somewhere around, I think, let's say 2,300 seconds, right? So it's going to take 2,300 seconds just for the for each loop to loop through those files. And if I divide that by 60, it's going to equal somewhere around 38 minutes. Okay, it's going to take 38 minutes just for the for each loop to actually go out there, get a file, or get the name of a file, pass that into a variable, pass the variable into the connection manager. It's going to take time for that to happen in the background. So we looked at some other alternatives, and one of the alternatives that we came up with here was a tool inside of SSIS called the multi-flat file connection. So let me go ahead and open up that package so that I can show you what's going to happen here. So this is my data flow task inside of this multi-flat file connection, or the package that's going to demo that, rather. And I have a flat file source component. Now notice there is no for each loop here. There is nothing that's telling this data flow what file to run. Here is why. This connection manager right here at the bottom, if you open this up, I'm going to show you how I have this set up real quick. What you want to take a look at is this little button right here, this little wildcard. This flat file connection manager, this multi-flat file connection manager, is going to go to this directory, and it's going to look for every single file that starts with test and then has a wildcard after it. So if it starts with TEST, it's going to pull that file and all other files into the data flow at one time. And this is going to perform very well, and this is a pretty cool functionality of the multi-flat file connection manager. So let me show you how you can get to that real quick so I don't skip over that. Down here at the bottom, if you right-click in your connection managers and then go to New Connection, and you scroll down here, that option is right here. Okay, so it's very easy to get to. It's extremely easy to set up. You just want to go in here, select that option, and then click Add. And then once you've added it and you've hard-coded that first file, you can come in here and add an expression to it. So the way I got that wildcard appended to that Browse button is by coming into the expression editor of that flat file connection manager. So if I right-click on the bottom here and go to Properties, I'm going to show you over here on the right-hand side how I set that up, okay? So let me go ahead and zoom in. All right, so in my expressions, if I click on this button here, inside of my expressions of the flat file connection manager, I chose the property for the connection string, and then the expression that I put in here, let me go ahead and pull that over, is the directory location and as well as the test and then the wildcard. Okay, so inside of that directory there, I have about 1,100 files. I don't have 7,000 files, or this test would never end, but I have 1,100 files there. All right, and that's all you have to do to set this up. So just like the cache connection manager or the transform that we used earlier, it's very easy to set up, and this might be something that you might be able to use in one of the packages that are inside of your environment. So I'm going to zoom out, and I'm going to go ahead and execute this task real quick, and I'm going to show you how long it's going to take SSIS to actually loop through, or not even loop through, just to process those 1,100 files that are in that directory. All right, and it's done. So inside of each one of them files, I only have about 100 rows. Once again, the performance. So take a look at the way it's processing here. Hey, I have a file, it's ended, I started, I have a file, it ended, it started, I have a file, it ended, it started. It's very clean inside here. It's not doing a lot of validation or ending or cleaning up. And I'm pointing this out for a reason, because when I show you the for each loop container in just a second, you're going to see and be able to compare and contrast the difference between what you have here. So I ran that. It processed 1,100 files, and it did that in 6 seconds. 6 seconds, it processed 1,100 files. That is very fast. Very, very fast compared to what you're going to see here in just a second when I do the for each loop container. Okay, so I'm going to go ahead and stop that. And I'm going to go ahead and open up this other package here. Now in this one I'm doing the same thing, and I'm going to run through this real quick because this is recorded. So if I did anything in the webinar here today and you forget exactly how something is set up, you can go back and watch the recording. So I will go through the steps real quick just so you can see exactly what I did here. On the collection page here, I selected for each file enumerator from the top. I then pointed out the folder where all of those files were located at. And I'm telling this for each loop container, I'm saying, hey, I want you to go to that folder there and I want you to pull back every single file. I've just used a flat wildcard here that said wildcard.wildcard, right? So it's going to pull back every single file there, and it's going to give me the fully qualified destination. The fully qualified destination is actually going to be the directory location, so C:\\\/ssis blogs \\, and then it's going to give me the name of the file as well. And then I'm taking that and I'm storing those files. I'm storing them in this user variable here. So the loop container is going to pick one file at a time. It's going to go out there, it's going to grab the first file, and then it's going to put that file into this variable here, right? Once it gets that file and it puts it in that variable, it's then going to pass that variable to the connection string, and you can see I have an expression here. It's going to pass that variable to the connection string of this flat file connection manager. And that is how this connection manager here knows exactly what file to pick up and process. So when I run this package, the for each loop is going to process one file at a time. It's going to go get one file, it's going to put it in a variable, it's going to pass it here, it's going to process it. Once this is done, it's going to go back to the control flow. The for each loop is going to grab another file and it's going to say, hey, I want you to process that. So let's go ahead and execute this package so we can take a look at the performance difference that we got. Now remember, we just did the multi-flat file connection test, and that took, I think, 12 seconds or 6 seconds, something very fast, okay? And this is not taking that slow. If you come over here and you look at the data flow, you can see this is flying through those files. And I really like the for each loop container. It gives you more functionality. It gives you a little bit, a larger range of flexibility as far as what you can do inside of your package because you are performing operations on a file-by-file basis. However, it does take time to go out there and pre-validate, pre-execute, and do all of those steps that it has to do when it's using the for each loop container. And when I flip over to the progress tab here and I go through it, you can see this is nowhere near as clean as the multi-flat file connection manager. It's having to come in here and begin the execution phase, pull in the file, start the file, and then do some work, and then it has to do its post-execution phase here. So it takes a long time, not a long time, it's fairly quick, but if you're working with a lot of files in your environment, you probably want to try to find a better design pattern, right? Because I don't know about you, but 30 minutes to process 7,000 files is just not, it's not usually going to fall within the SLA that I have agreed upon with, okay? So you can see right here, it's processed, at this point, it's processed about 400 files out of those 1,100 files. So it's not bad, it's not performing poorly. This is probably going to run in about 10 minutes, but definitely not 12 seconds, okay? And it's something that, if applicable to your environment, you can set this up very quickly and see a huge performance improvement without really having to do that much work. So I hope somebody out of the 206 people now that are on this webinar today, somebody will actually find that helpful and be able to use that out there in their environment, okay? I'm not going to let this run all the way. I think it's very clear to see, you know, that this is not going to perform as well as the multi-flat file connection manager just based on the way that they're set up and the way that the data has to be validated, okay? So I'm going to go ahead and stop and debug. And we're actually doing very well on time. I only have one demo left here, so I'm pretty excited about that because I did not have, I just didn't have time to actually do a time trial this week. But I think that Brad Schatt will actually be on the call here at the end and be able to answer some questions if anybody wants to ask Brad Schatt directly any questions for this webinar. All right, so the next thing I want to talk about is blocking transforms inside of SSIS. So we've talked about blocking transforms in the past. You've probably heard asynchronous versus synchronous, or you've heard there are blocking transforms, partially blocking transforms, and there are transforms that don't block at all, right? And the problem with blocking transforms is twofold. The first problem is that it can't, any of the transforms that come after that blocking transform are kind of waiting in line, right? Because the data that's flowing down the data flow can't get to those transforms, and they can't perform the operations that they need to perform. And when they can't perform the operations that they need to perform, you have this bottleneck in performance inside of your SSIS package. So the general consensus in the SQL community is, you know, if you have a blocking transform, and I'll name a few of those real quick, just off the top of my head, right? If you have a blocking transform, a sorting transform, an aggregate transform, a merge join transform where you're having to merge two sets of data together. If you have any of those transforms there that are blocking the flow of data, if you can do that inside of your execute SQL statement, 95% of the time, that's where you want to do it. Excuse me. So 95% of the time, that's where you're going to want to perform that operation. There are going to be some one-off situations. There are going to be situations where you actually want to do the aggregation inside of SSIS. I won't get into that today, but I definitely had a situation where I was able to do the aggregate inside of SSIS, and it performed much, much better, but it was because of the design of the package. So what's going to happen here is I'm going to go ahead and open up the second package that I have, and the second package here is using SSIS best practices. And if I open up the old DB command, you can see that I'm bringing in my source. Let me go ahead and zoom in here. I'm bringing in my select statement. I'm bringing in all the columns that I want, and I'm also going to order by the customer key. So I'm doing that order, that sorting operation. I'm going to do that inside of the package here. And once again, this is twofold. So remember that blocking transforms, yes, they block the data. They block the data from getting to other transforms. That's the obvious performance degradation result that you're going to expect from using a blocking transform. But there's something else that I want to show you here before we get done today, okay? So I'm going to go ahead and run this command here, this execute task, and this is using T-SQL. This is going to run in about 3 minutes. And while that's running, I actually lost one of my SQL statements here because I hit the wrong button earlier, so I'm going to go ahead and pull that back up because there's something I want to demonstrate. So if you are on SQL Server 2012, if you are using SQL Server 2012, if you come into your SSIS DB here, and let me zoom in for you, there is actually a table value function here that's pretty cool. Okay, and this is it right here, this catalog DM execution performance counters. This table value function is going to allow you to see your buffers that are being used inside of SSIS. So if you don't realize this, if you don't know this, and I don't have enough time to actually, well, that's not what I wanted to do. Let me go ahead and close that out there. What I wanted to do was select star from, let me go ahead and pull that over here. All right. And then I'm not going to pass in an execution ID. I'm only going to be running one package here, so I'm just going to put a null value. But inside of the data flow, it uses buffers to process the data. Ideally, you want the buffers to work in memory. SSIS is designed to work in memory. It's an in-memory operation. It's going to perform significantly better if you can do everything in memory. And I think we've discussed that already, right? However, once you run out of memory, once SSIS does not have enough memory to allocate to one of those buffers, it spills that information over to disk, and it starts to process that information on the disk instead of in memory. And that's where you're really going to see some performance hits inside of your SSIS package. That's not good. It can cause some really bad problems if you do that. A, it's going to kill the package that you're currently running because now you've consumed a lot of memory that you didn't need to consume. B, it's going to affect other packages, right? Because you only have so much memory available inside of your environment. So if you've used up that memory inside of this package because of a poor package design, it's going to hurt other resources inside of SQL Server that also need to use that memory. This, to me, is a much, much significant worse result of actual blocking transforms than the fact that they just block data and hold up other transforms. Because once you get to that point where you start spilling buffers to disk and performance slows down, it slows down for everything, it's going to hurt you pretty bad. Now, unfortunately on this machine, once again, I have a very good machine. It was very difficult for me to actually replicate the performance problems that I've seen in the past on this machine and on this laptop. But I am going to show you how that runs. Did I not run this package here? Okay, it's running. Let's see how long this has been running for. 11:41, so right at about 3 minutes. This will be done in just a second. And this is doing the sorting inside of the data flow task, okay? And you can see here I added an annotation that says, hey, this is going to run in roughly about 3 minutes and 30 seconds. All right, so I'll expect that to complete here in just a second. And then I'll run this sorting transform. I'm actually not going to run it live. I'm going to run it from the Integration Services Catalog, and the reason I'm going to run it from the Integration Services Catalog is it only logs information to the database if I run it from there so that I can see the actual results of the buffers being used. If you are not on 2012 and you're still interested in being able to actually monitor those buffers, the buffers in use and the buffer spooled, you can still do that, and the way you do that is using a tool called perfmon, or Performance Monitor. And Let me see if I can pull that up on my computer real quick. All right, and let me slide this over. So if you open up Performance Monitor on your computer, what you're going to look for here, and we are not going to have a lot of time to really set this up, but if I go to my Performance Monitor, I can see that it's currently monitoring processing time down here at the bottom. You can come to this button right here at the top and actually add additional counters here. So if I hit Add, and I go in here to my local instance, I can come down here to SQL Server SSIS, and let me show you where this is so you can try this on your own machine if you're in 2012. You can come down here to SQL Server SSIS, and then you can actually pull in your buffers in memory, your buffers in use, and your buffers spooled. Now remember, anytime you get any values in buffer spooled here, that's not a good thing. That's not what you're looking for. And then all I have to do is just add this. And when I add that here and click OK, it's now going to process that information, and I can go to a report, and I'll be able to monitor that information right here inside of Performance Monitor. So if you're on Performance 2008, you don't have 2012, and you don't have that SSIS DB that you can rely on that I just showed, then you can actually still get that same functionality here. Okay, so I'm going to go ahead and close that out. And this is taking a little bit longer than I expected. I'm probably going to kill this process in just a second for the sake of time. I think that this query actually brings back about 30 million records. So it's a pretty large result set, and it has a lot of columns. Okay, so we're at 20 million here. So it ran 20 million records in about 5 minutes or 4 minutes. I'm going to go ahead and cut that off. And the reason for that is obviously the query's done, all the data's been sorted, so now all it's going to do is run through that. It probably only had a minute left, but I want to go ahead and jump back into SSIS, and let me show you this package here. So what's going to happen in this package if I run it locally? I'm going to execute it just for a moment so that you can visually see what's happening here. Every time you see this number changing right here, this number right here, every time it changes, what it's doing is that's a new buffer that just ran into the data flow, and it's being loaded into the sorting transform. And the sorting transform, notice that it's blocking. It's not letting anything go down the data flow. This is extremely bad for performance for the two reasons that we've already discussed. Those buffers that were in memory here, that first buffer, that second buffer, that third buffer, when that buffer gets all the way down to the ODB destination and it loads that information into the destination, that memory that was used for those 10,000 records or however many were inside that buffer, that memory gets freed. SQL Server frees that memory, and now the data flow task can use that memory again. It can use that same memory again, and it doesn't have to spill that information over to disk, right? So it goes out there and says, hey, we have 10,000 more records in our source that we want to process. We're going to load this into a Biff buffer. Is there any memory available? And it sees that consistently throughout the package, memory is being freed up because every time the buffer hits here at the bottom, it's freeing that up. I'm going to stop this so it doesn't kill the memory on my machine, okay? But you can see that what it's doing there is it's actually stopping the data flow, and it's not letting it go down, and it's not allowing those buffers to be emptied and then release that memory that has been consumed. What I'm going to do for this demo, and what I had planned, was to actually flip back over to SSIS here, and I'm going to go into my integration services. Once again, if you're in 2012, you can actually perform this exact same demo here. And I'm going to run this sorting transform right here. Okay, and I'm going to go ahead and execute that. And when I execute it, it's going to ask me, hey, do you want to show the report viewer that is available in 2012? I'm going to say no. And now in the background, this package is running. And how I can see that is if I run this SQL Server command here, and I need to change my database. Hold on 1 second. This is pretty cool. Okay, so I'm going to change this database here. And what I can see, and this is what I want to show you. Let's drill in here. The buffer spooled, 0. Everything right now is being done in memory. Everything inside of my package is being done in memory. If I run this again and I hit F5, I can now see that my buffer spooled is up to 43. So it ran out of memory. It has processed roughly 6 million rows, and once it hit those 6 million rows, it has spooled that information over to disk. Okay, so this is where you run into problems, and this is something you want to monitor inside of your SSIS packages if you're having performance problems. I was actually working with a client just the other day that was saying, hey, how come when I'm running this package, this is what's happening, and when I was demoing the same exact thing on my machine, and they had it on a pretty heavy server, on my machine it was performing twice as fast. This is why. My machine was doing everything in memory. Their machine was actually spilling over to disk, and it was performing much worse. So this is something that you want to monitor, and if I hit F5 and I keep monitoring this, I'll see that it's just continually pouring information into the buffers, and it's spooling that data. All right? So I'm actually going to come in here to my active operations, and I'm going to kill this process here. or else I'm not even going to be able to move around. No, I hit the wrong button. I apologize. Let me open that up one more time. And what I want to do is go ahead and stop this process. And I'm going to click OK. All right, and I'm going to click Close. All right, and let me flip back over to SQL Server Data Tools. All right, so I went through everything that I put together for this webinar today, and it looks like we still have 10 minutes available to us for actually answering questions and going over any specific details that anybody might have. So Liz, I'm going to turn it over to you, and if Bradley is here and Brad wants to jump in, he can do that as well.
Okay. Brad, do you want to go through the list of questions?
Yeah, so great job, Mitchell. Definitely some really good stuff in there, performance tuning wise that you showed. We do have a couple of really good questions here as well. This first one, I'm not sure if you actually showed this or not, but somebody was asking about doing select star versus checking off the columns in the connection manager up there, as far as performance gains, what those two situations do for you. So if you just open up one of your data sources there for me, if you don't mind. And we'll kind of show everybody what we're talking about here. So what's basically happening here, and as I'm sure you already mentioned this, is what we're doing is basically doing a select star against the database. And then on this screen here, we can actually come in and we can check off individual columns and tell it that we don't want to bring it back. Well, while this is going to help to a certain extent with your performance by unchecking certain columns inside of here, ultimately, in the background, what that's actually doing is it's still issuing a select star against the database. So you're not going to end up seeing a whole lot of performance gain by just choosing a table and then unchecking the columns in here. You're definitely much better off going through and actually telling SSIS, here's a query and this is only bringing back the columns that I need. Well, it will help with some downstream operations, and if new buffers are created and those types of things, it's not going to help actually pulling that data over the network, because it's going to pull it over the network into the SSIS engine, and then it's going to eliminate those columns at that point. So you will still end up with some issues there as well. A great way to be able to identify these is if you ever run an SSIS package and you have some columns that aren't used inside of there, if you look at your warnings on the progress bar there, if you look at the warnings afterward, and it may not do it in this case since you have that terminator destination there. Oh, actually it does. So you'll notice that you get those errors or the warnings that say that you have a column that's not used, and removing them will help increase the data flow performance. So always keep a lookout for those warnings in there, and that'll help you narrow down and limit which pieces of data you actually need to exclude from there. Okay. One of the other questions we have in here is, relating to the bulk insert versus the fast load options there. We had quite a few questions about situations. There's definitely, as everybody saw, the value between setting that option over to the fast load. But somebody asked a very good question is, why would you ever not use the bulk insert mode? So what actually happens, and as Mitchell saw there in the profiler trace that he ran, was when he ran it the second time with the fast load option, you saw, was it probably 5 or 6 different insert statements, right, Mitchell, about that, somewhere around there?
Yeah, somewhere around there.
Yeah, so what it was basically doing is, the reason why you see those 5 or 6 as opposed to the 51,000 that you saw in there previously was it's actually taking each of those buffers and it's committing those buffers individually. So it's doing it in bulk, and it's doing much fewer commit statements. So the reason why you may want to actually use the non-bulk insert option is, let's say we have a record inside of that buffer that's going to cause a failure. So it overflows, a numeric overflow, or maybe it's a varchar 50 and you're trying to insert into a 25. What's going to happen is, with the bulk insert mode, it's going to actually take and throw out that entire buffer. So all 10,000 or right around 10,000 records are going to get thrown out. It's not going to commit any of those to the database. Whereas if you do the row-by-row operation, it's going to commit those rows individually, so only the records that are actually causing you problems will get thrown out and not committed to the database. So you can do a little bit better error handling whenever you use the non-bulk insert mode. That being said, the benefits of doing the bulk insert mode are more than likely going to outweigh the necessity to do some of those other troubleshooting things. And you can always go in and you can change those settings later on and do those for the fast load option, and then switch it over to the individual records if you need to. So that would be really about the only situation that I could think of off the top of my head as to why you would not use the fast load or that bulk insert option there. Unless you had anything to add there, Mitchell, maybe something else that you've seen.
No, I've never seen any scenario where I've used that. Like you said,
Okay.
the benefit of using the bulk insert definitely outweighs the troubleshooting there, and there's some other designs that you can put in place to try to handle those errors.
Yep, absolutely. So let's see. There was another question about whether or not on the multi-file connection manager, whether or not you can specify individual file types. So when Mitchell did that, he set up with the wildcard at the very end. So he said test star, I believe, was the command that you had in there, right? So if you wanted to, you could actually, that wildcard can be anywhere in there. So if you needed to do like only test.txt files or .csv files, you could absolutely do that as well. So you know, the way that he had it set up, he's only got the files in that particular one that he needed to pull in, so he didn't need to add the actual file extension on the end of there. But you definitely can do that, and that wildcard will work other places inside that connection string there as well. One other question, real good one here, as far as versioning features over the different versions of SSIS here, were whether or not that flat file, the multi-file connection manager, is available in versions prior to 2012. And I went just to verify it. I went onto Books Online, and that actually was introduced in SSIS, so it's in there as far back as the 2005 release for that particular connection manager option. Let's see, we had a couple others coming in here while we were talking here at the end. Let's see here. There's a couple questions in here about recording. Liz will make mention of this here in just a moment, but definitely all these sessions are recorded. So if you need to go back and review any of these particular things that Mitchell showed you today, take a look at how to reset those up. You're more than welcome to go review the recording later on here. And one last one here. So there's a question as far as resolving some of the blocking issues. So on the last one there that Mitchell showed with that sort transform, really the only way to alleviate some of these blocking issues, and Mitchell had made mention of this as well, is to do some of these operations inside of T-SQL rather than doing them inside of the database here, or inside of the SSIS engine here. So there are situations, again, you know, we could probably figure out some examples, and I know Mitchell's had some situations where he's had to do some of these operations here inside of SSIS. You know, whether that's something like where you're bringing in data from a flat file source and you can't sort it inside the source, so you have to do some of those things here, or you have to land the data, some of those kind of things. But if a transform is fully blocking or partially blocking even, unfortunately, the only way around those is to stage the data and try to do those types of transforms someplace else. And inside of SSIS, they're coded the way that they are, and there's not really a way for you to be able to take this fully blocking transform and the sort transform and switch it over to a partially blocking transform. Okay?
Right. And on that point, I actually do have a blog out there on my website of a situation that I came across where I used the aggregate transform inside of SSIS instead of T-SQL. So a pretty good example out there, and once again, it's mitchellsql.wordpress.com if you want to go out there and just read that blog to kind of follow up on that question. So thank you, Brad.
Yep.
Is there anything else?
No, there's a couple other little ones in there, but we'll make sure to get the rest of these questions over here to Mitchell afterward, and have him post some follow-up on his blog there. So if anybody else has any questions, I know we're kind of out of time here. Liz will do a little bit of wrap up here, and then we'll definitely get those other questions answered for you guys. So thank you again, Mitchell, for taking the time to do this today. We really appreciate it. And Liz, we'll hand it back over to you.